Hi, this labcast is about the respiration response lab. We're going to test the effect of hypo and hyperventilation on lung function. Hypoventilation referring to breathing at a low rate, and hyperventilation referring to breathing at a rapid rate. Something about this regulation of respiratory rate. In the heart, at the aorta, the aortic bodies, and at the carotid artery, the carotid body, there are sensors that detect the amount of carbon dioxide in the blood. And as they detect changes from set point, they relay messages to the brainstem, the breathing centers of the brainstem, which will then send messages that will allow us to increase or decrease respiratory rate in our lungs. In order to detect our lung function, we need labcast. That's our device. Then we need our spirometer. So we're going to connect our spirometer to labcast. We're going to connect our spirometer to a filter to kill germs. Then, of course, our disposable mouthpiece. Connect them all together. Put our mouth here. We breathe in and out at the device, and the labcast will sense our lung data. So when you connect your spirometer to your labcast, you want to make sure that you're going to collect data for 120 seconds. In that same menu, you make sure you also set it for 100 samples per second. Then when you're ready to start the experiment, you start by inhaling and exhaling 4 times. And then for the first experiment, you're going to hold your breath for 40 seconds. And make sure you take one large deep breath. Then after you do that for 40 seconds, then you're going to, breathe as normal as possible. And then the data collection will stop at 120 seconds. The second experiment, basically everything is the same except for you're going to hyperventilate in that experiment. So inhale and exhale 4 normal times, and then you're going to breathe rapidly for 40 seconds, then try to get back to normal, and then the data should stop at 120 seconds. So when we collect our data, it's going to look something like this. So we inhale, exhale, inhale, exhale, inhale, exhale. In this case, this is the hypoventilation, where we inhale and hold our breath for an amount of time, and then we see how our respiratory rate changes. One thing I should point out is that your graph is not going to look like this exactly when you first collect your data. You might have to tap on the labcast on the axis to change this one to volume. And it should have time on the x-axis, but if not, then you just tap on the bottom to change the axis. Once we get our data, we're going to perform some calculations. First thing we're going to calculate is the tidal volume, and that's basically the amount of air we breathe in and out. So we need to find a representative peak and valley and find out the difference in volume between here and here. Don't be confused by the negative number here, just sort of a quirk of the labcast. Sometimes we'll get the negative numbers, but the calculations still work regardless. So we have our volume at peak A, which is at 1 liter. Volume at valley A is -1. So we do the math. We have 1 minus -1, which is 2 liters. The next thing we need is our respiratory rate, which is basically the number of breaths we take per minute. So what we need is a 2-step calculation. We basically need the time difference between peaks or between valleys. I'm just going to do this difference here. So we have the time at peak B at 45 seconds, at peak A is 15 seconds. So I just write this out. 45 minus 15. It's going to give us 30 seconds. Then we're going to take 1 minute and divide it by the amount of time for one breath, basically. And then we get 2. So basically we breathe 2 times per minute, which makes sense because you look at 60 seconds, you see that we basically breathe 2 times. So it works out perfectly. Then we get our minute ventilation, which is the amount of air we breathe per minute. So we have the volume for one breath, and we know the number of times we breathe per minute, then we know how much air we breathe in a minute. So we get our 2 liters times a respiratory rate of 2, and that gives us 4 liters per minute is our minute ventilation. So you'll perform these calculations for the data we collect in the lab. Thank you.